All right, guys, here we go. This is the last piece of the lesson, and this is on logarithmic differentiation. So logarithmic differentiation is a technique and not really a rule. It's a technique where you, wait a minute, I'm spelling and talking at the same time. All right, where you actually take the ln of both sides and then differentiate. And so the uses of it, there are two. One is for a function raised to a function power. There's no rule for that. There's a rule for a function to a numerical power and a number to a function power, but nothing for a function to a function power. And there is no rule for that. The logarithmic differentiation is the only technique that will work on that derivative. And the second one is when you get an algebraic function that's just ridiculous, like the cube root of 5x minus 1 to the 5th times 2x plus 3 to the 4th over 3x minus 1 to the 7th and 2x plus 9 to the 10th. Something like that, using conventional methods, the chain rule, the product rule with the quotient rule. You've got all of those in there. Take you forever to do. Something like this, though, the answer would not simplify easily, and no one would expect you to simplify an answer like that once the technique of logarithmic is used. This is really the main focus of logarithmic differentiation, to treat these functions to a function power. So the technique is to take the natural log of both sides. So you take the ln of both sides of the equation and then differentiate. It's as simple as that. If I can fit this all in here, it'll be a miracle. Yay. So I want all of that on a note card. The note card should read all of that. You need what the name of the technique is, its uses, and then what actually the technique would be. So taking the ln of both sides and then differentiating. I'm going to do an example of each one so that you can see how it's used. When you practice these on your mandatory assignment, you are only going to practice these. On the worksheets that I have, on the other mandatory assignments on the worksheets that I have, there are a couple like this that you will do as well. So I'm going to actually do an example of both, but on the first mandatory assignment, only one's like this. Okay? So pause it and then write your note card on there, and we will do two examples. All right, so example 1, we're still finding dy dx. Nothing different about that. But what's different is that we have y equals x raised to the x cubed plus 2 power. So again, there is no rule for that. Anytime you have a function raised to a function power, the only technique that works is logarithmic differentiation. So we're going to take the ln of both sides. So the ln of y equals the ln of x to the x cubed plus 2. And the purpose of the logarithmic, what it does, is it takes this problem child of this power, this function power, and because of the log property, it takes this function and drops it in front. So you get the ln of y equals this whole thing, right? This whole thing is the power. So he comes in front. So I'm going to get x cubed plus 2 times ln x. And now it's easy to differentiate. This is just implicit differentiation. We're going to find dy dx. So it's 1 over y times dy dx equals, this side is a product. So I get x cubed plus 2 times the derivative of this, which is 1 over x, plus ln x times the derivative of this, which is 3x squared. And then I'd have to multiply by y, so the derivative will be y times x cubed plus 2 over x plus ln x times 3x squared. And then you have options like here's y. You can put your original y back in or not. It doesn't matter. And this you could get a common denominator, but there's really no purpose in it. Like it doesn't really get any better. It just looks different. So I'm okay with the answer just as it is at this point. The key is to take the ln of both sides and remember that once you do that, this power comes in front and then that's a product, and so you have to make sure that you use the product rule. All right, there's really nothing more than that. All right, the other example I want to do is one of those weird ones. So let's just say we have the square root of 3x minus 2 to the 5th, extend that, times 5x plus 1 cubed over, let's just say 2x plus 5 to the 4th. You'll get the idea. So I know that this is y equals, this whole thing, 3x minus 2 to the 5th times 5x plus 1 cubed over 2x plus 5 to the 4th, and it's all raised to the 1/2 power. All right, so I could use the chain rule on that, but ooh, what a mess. So I'm going to try this logarithmic because I know when I have the ln of all of this, I've got log properties aplenty. So I'm going to try it. I'm going to take the ln of both sides equals the ln of this whole thing. So 3x minus 2 to the 5th times 5x plus 1 cubed over 2x plus 5 to the 4th, and all of it's to the 1/2 power. And since this whole thing is raised to the 1/2 power, it's a log, this 1/2 can come in front. So I get ln y equals 1/2 times. Okay, it's in front. Now I get the ln of the product. So remember, there's a log property that says the ln of a product means I can add the logs, and the ln of a quotient means I subtract. So I'm going to get the ln of 3x minus 2 to the 5th plus ln 5x plus 1 to the 3rd minus ln 2x plus 5 to the 4th. Okay, nothing but a log property and no derivative yet. Don't get all excited because there's no derivative done yet. So we're still simplifying. ln y equals 1/2 times, all right, remember here I got another log property. So he comes in front. It's 5 ln 3x minus 2 plus 3 ln 5x plus 1 minus 4 ln 2x plus 5, and that quantity. And now I've applied all the log properties there are, and watch how easy the derivative is. I get 1 over y dy dx equals, this is a constant, dropping down. And now I can just take the derivative of each piece. So I get 5 times 1 over 3x minus 2, because it's a log, natural log, times 3, plus 3 times 1 over 5x plus 1 times 5 minus 4 times 1 over 2x plus 5 times 2. And then just bring the y over. So dy dx would be 1/2 y times all of this, and no need to simplify. No need to simplify. So let me see if I can squeeze in the answer. dy dx equals 1/2 y times 15 over 3x minus 2 plus 15 over 5x plus 1 minus 8 over 2x plus 5. Done. No need to get a common denominator. No need to sub back in y. We've differentiated. If we needed to use this to find anything else, we would have it. All right. The first YouTube lesson is over. All 4 parts are complete. Make sure you look at your handout and make sure you have everything in on time and all parts of all lessons are completed. All right, good luck. And remember, listen for dates and times on class time and after school that we can go over questions if need be. All right, good job, everybody. See ya.